Good evening, sir.
Good evening. Good evening.
So I'm Dhananjay.
Yeah.
So can you please go into the breakout room?
Sorry, Dhananjay, I couldn't hear you.
So can you join to the breakout room, please?
Okay, okay, sure.
Good evening, everyone, and welcome to DECODE XTREME. I am Rusiri from the Media Unit of SLTC, and I'll be your MC for today's event. We are thrilled to have you all here for this exciting two-day awareness webinar series organized by the IEEE student branch of SLTC in collaboration with the IEEE Computer Society student branch chapter of SLTC. DECODE XTREME is designed to motivate and prepare all undergraduates for IEEE Extreme 18.0, a 24-hour global programming competition that unites IEEE student members from around the world to tackle coding challenges hosted virtually and proctored by local IEEE members. In our first session, we provided an overview of IEEE Extreme, including its significance, structure, and the variety of challenges participants face. We also shared insights on how to effectively prepare for this intense competition, emphasizing the importance of collaboration, problem solving, and practice. And today, you will gain valuable insights into competitive coding strategies, coding tips, and a deep understanding of the competitive coding requirements essential for excelling in the global IEEE Extreme competition. With practical tips and first-hand knowledge, DECODE XTREME will clarify the intricacies of the competition and inspire active participation from all of you. So, without further ado, let's kick off this event. I would like to invite Ms. Tarushi Nodurika, the Secretary of DECODE XTREME, to share her thoughts and officially welcome you all. Over to you, Ms. Tarushi.
Thank you, Rosary. Good evening, everyone. On behalf of the IEEE Student Branch of SLTC and the IEEE Computer Society Student Branch Chapter of SLTC, I am delighted to welcome you all to Session 2 of DECODE XTREME. This webinar series is designed to inspire and prepare you for one of the most exciting challenges in the world of competitive programming, IEEE Extreme 18.0, a global 24-hour coding competition. We are thrilled to have you back after the first successful session and look forward to building on the momentum with even more valuable insights today. Tonight, we are privileged to have Mr. Nimesha Jinarajadasa, a highly experienced professional who will be sharing his insights and expertise on competitive programming strategies and providing key insights into how you can succeed in IEEE Extreme. We hope that today's session will not only equip you with knowledge, but also motivate and inspire you to push your limits as we approach the IEEE Extreme Challenge. We encourage you to actively participate, ask questions, and make the most of this opportunity to learn from an industry expert. So, without further ado, let's begin what promises to be an insightful and engaging session. Thank you once again for being here, and I hope you enjoy the session. Thank you.
Thank you, Ms. Tarushi, for that inspiring welcome. Now, it's my pleasure to introduce our esteemed guest speaker for today. He is the lead engineer of DevOps and cloud-focused Code Cloud Singapore. Ladies and gentlemen, please join me in welcoming our esteemed guest speaker, Mr. Nimesha Jinarajadasa, as he shares his invaluable insights that will guide you throughout your IEEE Extreme journey.
Okay. Thank you, Tarushi. Thank you, Rusiri. Sorry if I pronounce, I think I pronounced the name correctly, right? So thank you all. So first of all, I'm like really excited to be here today. So like we are going to dive into competitive programming, right? And first of all, I would like to thank the IEEE Student Society, so in SLTC, right? So thank you for inviting me. So I'm trying my best to give something for you guys at the end of this session, right? Okay, so let me, I hope I'm audible, right, Tarushi or Rusiri? Am I audible enough, right?
Yes, sir.
Yes, sir.
Okay. Yeah, thanks. Okay. Okay, so first, let me share my screen. Give me a sec, guys. I'm going to share my screen. Okay, sure. Okay, so okay, guys. So I hope. Sorry, give me a sec. So I hope it's visible, right? My screen is visible. Can you confirm? Is it visible, guys?
Yes, sir.
Okay, thanks. Okay, let's start. Yeah. Okay. Hello, everyone. So good evening. I hope you're all doing well, right? So I need to ask one question first before diving into the session. So has anyone participated in the IEEE practice event yet? I think there was a practice event, right? I guess it was on last month, right? So anyone here who has already participated in the practice event? You can just, guys, I'm not a lecturer or anyone, so you can just talk to me. You can even unmute your microphone. You can talk to me. There's nothing to worry here. So yeah, so even you can push messages in direct messages in meeting chat as well. Yeah, yes. So Madhushan, so I think Madhushan is already participated in practice event, so that's really good, man. And I think the real event is on 26th this month, right? So if anyone knows the exact date, feel free to let us know, because I think this is going to be a session around IEEE competition, right? So we are going to face that. So there are nearly 50, 60 undergraduates here. So I hope you are aware of the competition date. Is it going to be on 26th on this month or? Okay. Anyway, I think it's on 26th, right? So October. Okay. So, so today we are going to dive into competitive programming. So what it is, why it's so useful, and how you can really sharpen your skills, right? So we are going to explore key strategies to help you solve problems more effectively, efficiently, right? And of course, we'll break down some algorithms and data structures today, right? So which are the backbone of competitive programming, right? And plus we'll go through a few examples step by step. I'm going to show you how you can approach a problem and how you can come up with a solution, right? Step by step, right? So guys, let's get started and have some fun today, right? So I think you are waiting for this, right? Okay. First, let me close this chat box. So, and before moving into the actually the slides, I'm not a big fan of PPTs, right? So I think you have had one session regarding, related to this event. So I think you might you are having some PPT presentations, right? So one thing regarding me, so I'm not a big fan of PPTs, right? So I think my last PPT was back in 2017 when I was at university, right? It was my last research presentation. So after that, I think I have not I have not created any PPTs, right? Even I'm not good in PPTs. So what I do is, in my spare time, what I do is like I share knowledge around Sri Lanka with many institutes, universities, right? So what I do is like I come up with some illustrations, infographics, and then using those I am explaining things, right? So that's my way. So you need to bear it for today if you are not feeling well with this kind of setup. So anyway, so I got a landing page today. So this is going to be my this is going to be the my kind of PPT, right? So at the end of this session, I'll be sharing this link, so you can go through this and you can have it as a reference material as well, right? So okay, yep. Okay, so first let me introduce myself, who I am. So a few years back, I used to be an algorithmic programmer, right? And I used to be a full stack software engineer. So I started my career at IFS R&D technology team. So I was a full stack software engineer. So, but um, within last 3 to 4 years, I made a complete 360-degree turn in my career to focus on DevOps and cloud engineering. So now I am not a full stack guy. Actually, I am a lead DevOps and cloud engineer. So I have made a 360 turn in my career. So So what I'm going to tell you here is I'm not going to teach you the ins and outs of programming, algorithms, or data structures in depth today, right? Because to be honest, I have lost my touch in those areas, right? So, and this brings me to my first piece of advice as well. So today's session is all about strategies, tips and tricks, advices, right? So first piece of advice is I'm going to give you at the beginning of this session as well, right? So if you want to be really good at solving problems and writing algorithms, you have to practice daily, right? That's how you stay sharp and in the zone, right? So because I know by my experience, because I'm nearly 10 plus years in IT industry now, right? So for the first 6 years, I was algorithmic programmer, like a full stack guy, doing software engineering stuff. But after in the last 4 years, I was not doing that thing. I was totally moving into the DevOps and cloud area, which is a trending field around the world, right? So what happens is like we are not much focusing on algorithmic problem solving in DevOps and cloud area. So what happens was like I lost my touch in this area, right? So what my first advice is, if you want to be really good at solving problems and writing algorithms, you have to practice daily. That's the only way that you can do this, right? So however, with my experience, I'll still give you a high level overview of some of the concepts that can help you improve your approaches, right, when it comes to competitive programming. Okay, so yeah, so let's start from the first question. What is competitive programming? So any of you here who knows what is competitive programming? I like to see your answers. So if you don't like to unmute your microphone and answer, you can just put the message in chat box, because this is going to be an interactive session, right? So you can add your answer in meeting chat. Like, what is competitive programming, guys? Any answers? Like, there's no right or wrong answers, right? So even I'm not sure about my definition as well. So you can push your answer towards me. Okay. So I think still the people are sleeping. So let's dive in. So what exactly is competitive programming? So you have probably heard about it being like a coding race, right? So where you solve problems within a limited time, right? So, but it's not just about speed always, right? It's about being, like clever with how you use your algorithms and data structures to find the most efficient solution, right? So that's the simplest idea behind competitive programming, right? So let me give some kind of example. So it's kind of like solving puzzles, right? So you might have you might solve some puzzles in your, like in childhood, right? So you know how to solve puzzles, right? So but in this case it is more like a puzzle, but this time it is with code, right? It's all about coding, right? So and why is this important? Why is this competitive programming is important? Yeah, well, apart from being a great mental workout, right? So competitive programming prepares you for coding interviews, right? And also real world challenges, right? So I need to say this, like you will find that these problem solving skills are super valuable, whether you are at a hackathon like IEEE competition. It's kind of a hackathon, right? So or in an interview, like you are going to face interviews within next 1 or 2 years, right? So this is going to be super important problem solving skills, right? So when it comes to your first interview, let's say you are going to join as an intern or even a junior software engineer to IT industry. So problem solving skills is the first thing that we are like we are checking. How's your problem solving skills? If we give some kind of a problem, it can be kind of a real world problem even. So what we check is how do you approach that problem? How do you come up with a solution? We don't expect 100% perfect answers in your interviews, right? What we expect is how you tackle problem, how you break that problem, and how you come up with a solution, right? So that's why I'm always telling the problem solving skills are super valuable, right? So even let's say you are going to work on your own projects, this is going to be really important, right? So let's say you are going to doing some freelancing stuff within next 3 to 4 years. So it's again really important you are having the right problem solving skills, right? So very important, guys, right? Okay, let's move into the next part. So I think this is this is one of the most important sections of this session, right? So what I'm going to do is I'm going to introduce you to some of these key strategies for competitive programming, right? So I suggest you to I'm sharing this URL with you. So keep this as a reference, and you need to follow these 6 steps, because I've been in the same situation 10 years back, and I know how important these 6 steps are, right? So I'm going to share it all with you, so you can follow these strategies, or even we can say these are tips and tricks, right? So yeah, let's say when you are tackling a coding problem, right, you can't just dive straight into writing code, right? So it's like, let's say, let's take an example, like let's say book author, right? So people who are writing books, right? So let's say someone wants to write a book, right? So he or she, they just don't sit and start writing the book, right? What they do is like they take time, right? They take weeks, maybe months, or even years to write the book. They're thinking the approach, they're thinking the title, right? So they are taking time. So same goes with this scenario when it comes to programming, right? So you can't just dive straight into writing code, right? There are few key steps that will make your life much easier and help you solve problems faster, right? So let me start with the first step, right? And probably the most important one, right, is to really understand the problem. The first bullet point, understand the problem, right? Think about that. So please don't rush into coding just yet, right? Always take a couple of minutes, maybe even 5 minutes, to really think about what's being asked, guys, right? So even in an exam, I think you guys facing exams in university, right? So you are getting the paper, and what you do is like you are just read the question and just start writing. That doesn't work. And after 10 minutes, after writing half of your answer, you are checking the question back again, right? So then the question is about other thing. Now you have spent 10 minutes on writing some other bullshit, right? So that's not going to work even with programming, right? So you need to take a couple of minutes first, or even 5 minutes, to really think about what's being asked. For example, if the problem says find the minimum value of something, right? So I'm taking just an example, right? Find the minimum value. Don't mistreat that and start summing up numbers, right? That's what we always do. Even I've done that, right? So you have got to make sure you know exactly what the problem wants, right? So this is really, really, really important, guys, right? So what the problem wants, so what is the input, right? What should the output look like, right? Are there any constraints or tricky conditions, right? So you need to think about these things. To think about these stuff, you need to take some time. You need to take a couple of minutes and read the question and understand the problem, right? So yes, slowing down at the start to fully understand the problem can save you from hours of debugging later on, right? Trust me, this has happened to me many times at early stage of my career. So we are not just trying to understand the problem, but we are just jumping into the solution. And what happens is like we are spending, later we are spending hours of time debugging our solution, right? Because we have not address the problem, like we have not came up with the proper solution for the given question or given problem, right? So because we have not understood the problem at initial stage, right? So this is really important. Okay, I think you got the idea. Let's move into the second point. Okay, now once you have got a handle on the problem, the next step is to break it down into small pieces, right? Break it down into smaller pieces. Very important, right? So let's think of it like building something, right? So let's take let's take a house construction. So you wouldn't start building a house by putting up the roof, right? Do you like do you do that? Like you start building a house by putting up the roof, right? It's not going to work, right? So first we need to have a proper foundation, right? Solid foundation. So first we need to have the foundation for the house. Then we need to have the walls or the columns and then the beams, right? Then the roof comes, right? It's the last thing, right? So we need to start from the foundation, right? So for example, let's say if you need to sort an array, right? Hope you all know about arrays, right? If you don't know about arrays, just don't participate in the IEEE competition. Just go and do the homework, right? So I'm just kidding. So just try to learn what arrays, right? So if you need to sort an array, you wouldn't think about sorting the entire array right away. Don't do that. First, focus on something small, like comparing two numbers, right? Once you have figured that out, you can build on it and handle the bigger problem, right? So that's how that's a way to approach, right? You need to break things, right? Break the large problem into smaller parts, right? So this is very applicable for even for the real world scenarios, right? So programming is even it's similar to real world things, right? Because we are solving real world problems, right? Programming is about creating software applications, products to solve real world problems, right? So in your life, even you might be getting a relationship problem, right? So even you might be getting a financial problem, right? Big problems, right? So what you need to do is just use this strategy. Break the problem into smaller parts. So if it is a relationship problem, so break it down. Take the first part, solve that. Take the next part, solve, right? So likewise, when you are in coding, you need to do the same thing. Break the bigger problem into smaller parts, right? So try to get the understanding, right? So that's what I'm trying to give you, right? So this step-by-step approach helps you avoid feeling like overwhelmed, and it also keeps your code organized and easier to debug, right? Super important, right? Second point. Okay, let's move into the third one. Start with simple test cases, right? So before you get too deep into coding, right, always start with the simplest possible test cases, right? So this is again one useful tip, right? For example, I'm taking examples because example-driven scenarios would give the proper understanding, right? So that's why I'm trying to give examples and explain to you. So for example, if you are checking whether a number is prime or not, right, don't immediately test like huge numbers like 100,000, right? So don't do that, right? So you need to check whether a number is a prime, right? Prime, do you know what is a prime number, right? I hope you know about prime numbers, okay? So if you need to check whether a number is prime, don't immediately go and test huge numbers like bigger numbers like 100,000, 1 million, likewise. Don't do that. Start with smaller numbers like 2, 3, or 5, right? So if your solution doesn't work for these small cases, you will catch the mistakes early on, right? That's why we need to go with simple test cases. It's like testing the foundation of a building before you start adding more layers, right? On top of, right? So you want to make sure your basic logic is solid before scaling up. These are very simple things, right? But we always follow the we are always getting the wrong approach. So start with simple test cases. So we need to have solid foundation before scaling, because we need to have some kind of a solid algorithm first. Then based on that, or then on top of that, we can scale up, right? We can, after we have a solid foundation or we have a solid algorithm, then we can test for the 100,000, right? Likewise, you can go beyond and test for the bigger numbers when it comes to this prime number scenario, right? So work with the easiest inputs first. That's my advice, right? Easiest inputs, right? Okay. Next, something that I used to do. Even I follow this strategy or tip in my day-to-day activities, in my office works as well. So please get used to this thing. Use pen and paper. So this is not only for these type of hackathons or programming competitions, right? So even when you get a problem in your life, pen and paper is a like most cost effective resource that you can use, right? So pen and paper, right? So use pen and paper before jumping straight into coding, right? So sometimes it helps to sketch things out, right? Or let's say draw a diagram or write pseudo code to visualize what's happening. So do that first. So these might help you understanding the bigger problem, right? So use pen and paper. Don't hesitate to use pen and paper, right? So kind of a tip here. I'm going to give a tip. Let's take an example. So if you're going to sort an array, right? For example, you can do like this, something like this, like sketch out how numbers will move or change positions. Right? You can sketch that. I'm not telling you to go take 1 hour to do the sketching and everything. And okay, now after 1 hour, you have the perfect sketch. Now you look into the timer. Okay, time is up. Competition is over. You have the nice sketch and go home. So that's not going to work, right? I'm telling you need to practice this skill, like use pen and paper in a proper way, right? So in an array example, sketch out how numbers will move or change, right? Positions. It makes it easier to avoid like logical errors and see the bigger picture, as I've told, right? So before you start coding, try to visualize the steps. So it can save you a lot of time later, as I mentioned in earlier steps as well. So use pen and paper. Don't hesitate to use these, right? So these are everyone can have pen and paper, right? So when you participate in these competitions, always go with the pen and paper, right? Okay, let me go into the fifth one, the optimize later. Optimize later. So this one is again really important. So I'm telling important for everything. So because everything is important, right? All the 6 steps are important, right? So your first goal should be to get a solution that works, right? When you are in a, let's say, competition, hackathon, or even you are in your office, now you are a software engineer, so you have a problem coming from your technical lead or tech lead, right? So you need to solve that. You need to come up with a solution, right? So your first goal should be to get a solution that works, right? So even it's slow, that doesn't matter. So how to say? So let's say you are coming up with some kind of a solution for a given problem, right? But let's say it takes 30 seconds to execute and give the exact result, right? That doesn't matter, man, right? Because you have the solution now. You have the logic, solid logic. The only problem is it's taking some time. It's not efficient. So that's another thing. We can handle that, right? So first goal should be to get a solution that works, right? So don't worry about making it perfect right away, right? We can't come up with perfect solutions. So even I am 10 years now in IT industry. So, and even I got architects who is having 20 years of experience, right? But what I've seen is like programming is an art, right? So coming up with solutions is kind of an art, right? So for a given problem, there are many solutions. So different people can come up with different solutions, right? I mean, solution might be the base is same, but different approaches, right? So we can't say this guy's answer is the perfect one or this one is a perfect one. There's no perfect solutions, right? So even we can't make it perfect right away. Like at the start, we can't come up with a perfect solution. Doesn't matter how much experience you have, you can't come up with perfect solutions, right? So sometimes we get caught up trying to write the most efficient code from the start and we get stuck. That's what happens to many junior level software engineers I've seen. Like what they think is like they need to come up with perfect solution at the start. Then they get caught up trying to write the most efficient code and from the start and they get stuck. So don't do that. Come up with a solution, right? We don't care about the whether it's slow, it's fine because we are just They're just taking off, right? So one thing is like it's much better to get a working solution first, even it's like brute force, right? Once you have got that working, then you can go back and optimize, as I already told, right? So for example, if you are searching for a number in an array, I'm taking the same example. If you're searching for a number in an array, start with the simple linear search, right? Linear search. After that's working, you can think about improving it with binary search or something faster. Right? So, linear search is not the fastest way to do this, but just come up with some kind of a logic, right? To search a number in an array using the linear search. That's fine. After you got the solid foundation, you can work on the next part. Like you can think about improving it, like come up with binary search, right? So very important, optimize it, but don't try to optimize at start. Then what happens is you get caught up with something, right? So don't try to do that, right? So I think I'm getting a message. So guys, give me a sec. Someone message, is it true software engineers will lose their jobs in the future, right? Very nice question. So I'm going to answer these questions after. Is 8:40, I guess, right? So I'm going to answer after 9:05. Yes, after the session, I'm going to answer all these questions, right? So I have nice answers for these, right? I'll answer. Thank you. Who is this? Okay, there's no name. Anyway, thank you for the question, right? Okay. Let me go to the final strategy that we are going to discuss. Focus on edge cases, right? So always think about edge cases. So these are the weird, tricky situations where your code might break, right? Very weird things, right? Even in our life, we have edge cases, right? Weird, tricky situations that we might not expect, right? But we need to think about these edge cases as well. Especially you are participating in this kind of a competitive programming, like hackathons or competitions. So you need to think about edge cases, right? So even these guys check for edge cases. If you are came up with some kind of a solution, they always test it with edge cases as well, right? So for example, something like this how to say, yeah, what happens if the input is empty, right? Let's say you have came up with some kind of a solution, and you need to think about what happens if the input is empty, right? And what if the numbers are really large, right? So maybe you have tested it for numbers like 2, 3, 5, 10, 15, 20, right? Very nice, the program is working fine. You think, okay, you are a hero, right? But what happens, we are going for a weird case, like we are providing, sorry guys, we are providing 100,000. What happens? Everything get crashed, right? So you need to think about, if the numbers are really large, how can I handle that thing in my logic, right? But if the array has only one element, let's say you are using an array to craft your solution, right? And yeah, you are writing the solution, and you are testing for normal cases, and you think, okay, now the code is working fine, my logic is perfectly fine, and your small brother or sister comes into your room, and he comes and enter one element to your array, and ask he's going to ask from you, like, is it working? So it's going to get crashed because you have not you have not thought about what if the array has only one element. So these are the edge cases. I think you got the understanding what are these weird, tricky situations that you might encounter in your solution, right? So always ask yourself, what's the most unusual input this problem might have? That's the only way to tackle this thing, right? Once you have came up with some kind of a solution, solid foundation, solid solution, then the next question would be, what is the most unusual input this problem might have? What if input is empty, right? What if this array has only one element? What if the number is too large, like 1 million? So ask this question and test those edge cases early as possible, right? So This will make your solution more robust and reliable, because even when you are in this IEEE competition, they are checking for edge cases as well, right? So, okay, so guys, I think someone was raising the hand. Maybe let's keep the questions for at the end of the session, guys. So sorry to so I can continue the session, because I think we got only limited time, so I need to cover everything. So let's keep questions at the end of the session, right? Okay, let me move into the next part. Right. Okay, now what we are going to do is we are going to talk about one common approach to getting your code to work, which is called as brute force approach. Has anyone heard about brute force approach? Anyone? I'm checking the message box. Have you ever heard about brute force approach? Okay, seems like no. Anyway, I'm going to explain. So the brute force approach is a most straightforward way to solve a problem by trying every possible combination until you find the right answer. Right? That's the simplest explanation that I can give for what is brute force approach, right? It's kind of a most straightforward way to solve a given problem. But what it does is it is trying out every possible combination until you find the right answer, right? So it is not going to be the most efficient, but it gets the job done, right? So these kind of things happen in your real life as well, right? So you can anyway come up with a solution and it is working, but it is not going to be the most efficient one. But anyway, it gets the job done, right? So that's what we call as brute force approach, right? For example, I'm going to give an example for you, so you might be getting the idea. So let's say if you have an array of numbers, right? And you need to find two numbers that add up to a specific target, right? So the brute force method would be to check every single pair of numbers in the array. So this is the code that I have written to solve this thing. Like so problem is, if you have an array of numbers, let's say we have 4 elements like 1, 2, 4, 6, 1, 2, 4, 6, right? So what we need to do is we need to find two numbers, right, that add up to a specific target. So let's say the target is 10, right? We have numbers 1, 2, 7, 9. So the specific target is 10, right? So now if you think about that question, 1 and 9 numbers are there. So 1 plus 9 is 10. So we have one couple, right? So one pair of numbers, right? So the brute force method would be to check every single pair of numbers in the array. So that's the way of that's a brute force approach actually. So if you check this code, let me explain it a bit. So let's take this one. Okay, let me take this one. So in this, if you check, the function has pair with sum. So the first, there are two for loops in this Python function, right? So in the outer loop, so we goes through each number in the array, right? It starts from the first number and checks it against all other numbers in the array. See, it starts from the first number. I'm talking about for loop, outer loop, for I in range length array, right? So see the technique that we have used, goes through each number in the array and it starts from the first number and checks it against I can see all the other numbers in the array, right? So then if we move into the inner loop, in the inner loop, it starts from the number right after the current number I, and this loop compares the current number array I, that's the current number, with every number that comes after it, array J, right? I'm talking about the inner loop, for loop, right? So then we have a condition. So inside the inner loop, there's this if statement that checks if the sum of the two numbers, array I plus array J, equals to the target, right? If they add up to the target, the function returns true, meaning a pair was found, right? So this is the logic. So if no such pair is found, going through all the combinations, the function returns false. That's the basic logic behind this, right? This one. So now the important thing is when it comes to brute force approach, this works fine actually. This works fine. You can find the correct, I mean, this is kind of a correct solution. But the thing is, we have couple of for loops, right? So when it comes to the what it means, it starts from the first number and checks it against all the other numbers in the array. So this is not going to be efficient. That's the problem. This might take time. It is fine if we have 5 elements, 10 elements, 20 elements. But what if we talk about an edge case, like 10,000 elements in an array, we are going to find the solution. Then this is not going to work, guys. This might take some time to find the solution for 10,000 elements array, right? So that's the problem with brute force approach. So, but anyway, this is very important. At least you have came up with some kind of a solution. As I have mentioned in my earlier strategies, you need to come up with this kind of a solution at first, at least, right? Because this is working fine. Then the next step would be optimizing this or pushing this solution into next level. I have done that actually. So optimizing with a hash map. So now one great way to optimize this kind of solution is using a hash map. So I am not going to teach you what are hash maps and everything here. You should know about hash maps. Hash map lets you store data in key value pairs. I hope you know this stuff, right? And it makes looking things up super fast than an normal the brute force approach, right? So instead of checking every pair of numbers, we can use this hash map to store the complement of each number, which is just the target number minus the current number as we go through the array. Then we can check if that complement already exists in that hash map, right? So this is the optimized solution actually. So this is also fine, but this is not efficient. So we are using a hash map, and what we are doing is we are optimizing our solution, and this is going to be very efficient. So if I go through the code in real quick, so here we got hash pair with some function again. So we have this scene variable here, right? So this is a dictionary or hash map. In Python, we call it as a dictionary, right? Key value pair. So the variable is seen. This will store numbers we have already looked at as we go through the array, right? Then we have only one loop here. In our previous solution, we were having 2 for loops, right? Inefficient, right? So in this case, we have only one loop. So instead of checking every pair like before, we only loop through the array once with this for num in array, right? Once. So for each number in the array, right, you can see what we do is we calculate the complement by subtracting the current number from the target, right? So complement is like complement equals target minus number. So that's the logic. The complement is a number that when added to the current number would give us the target sum, right? So then we have the if condition, right? So what we do is we then check if the complement is already exists in the scene dictionary. If it does, that means we have already seen the number we need to add to the current number to reach the target, right? So we can immediately return true. So I'm not going to explain everything, but I'm trying to give you some kind of an understanding how you can improve your code. This is the brute force approach. It get things done, right? But the thing is, it's not efficient, right? So you need to come up with hash map, right? Okay, so I'll be sharing this material with you. So just take some time and go through these 2 codes and try to understand, okay, how this first code has been improved into something very efficient using a hash map data structure, right? So very important. Try to understand these things. So let me move into the another important thing that I am going to introduce you here. Importance of algorithms and data sets. So I'm trying to go through in a real quick because I got something next for you guys to not then yeah, small problem for you guys, but let me check time. Okay, 8:50. Okay, so importance of algorithms and data structure. So now that we have talked about some strategies at first, right? So let's move into some algorithms and data structures. So I need to tell that data structures and algorithms are the backbone of solving problems efficiently, right? You need to keep that in mind, right? So let's start with algorithm. So what is an algorithm? What is an algorithm? I need to see an answer from one of you. What is an algorithm? You can put your answer in chat box. Guys, you can just push your answers. Guys, you need to know about algorithms at this point because we are going to participate in a competition, right? Okay. You know, an algorithm is basically a receipt for solving a problem, right? So algorithms can be, some are fast and some are slow, right? The more efficient your algorithm is, the faster your solution will run, right? So that's very important. For example, let's say if you need to sort an array, you need to sort an array, right? You can use bubble sort. I hope you have heard about bubble sort, right? But it is very slow. That is an algorithm. Bubble sort is an algorithm, but it's very slow. So what you can do is you can use quick sort method, which is much faster than bubble sort, right? So what is important for you guys is knowing which algorithm to use based on the problem. That comes from the practice, guys, right? That comes from the practice. So that means you need to work with bubble sorts. You need to work with quick sorts. You need to practice. Then only you can understand once you get some kind of a problem. Okay, now you are getting the idea. Okay, now quick sort is the proper algorithm for this scenario, right? So very important to know about algorithms. So I recommend you guys to go through all the basic algorithms like bubble sorts, quick sorts, and everything. Have a look, try to get the understanding and try to practice, right? Very important. Then the other hand, data structures are like another important thing. It is kind of a way of organizing and storing data, right? So that you can access it efficiently, right? Let's say if you need to store a collection of items, right? You might use an array. If you need to store collection of items, right? You might use an array. Straightforward, right? And if you need fast lookups, what is the best data structure? It's going to be a hash map. Hash map is the best data structure. So again, picking the right data structure can make your solution much more efficient, right? So understanding both algorithms and data structures is essential for competitive programming. Very important, data structures and algorithms. So data structures and algorithms are the heart of programming, right? If you are going to be a software engineer at some point, you need to have a proper data structures and algorithm knowledge if you are going to become a software engineer, right? Or a algorithmic programmer, right? So very important, guys, right? So think about that, right? Let me move into the next part in a real quick. So now I am going to give you some key algorithms for competitive programming. So you need to go through these. This is your homework. So sorting algorithm. So sorting comes up a lot in coding problems, right? Sorting, right? So whether it's ranking items or processing data in a particular order, you need to sort things, right? You know that. So there are different sorting algorithms. So the most popular ones are like bubble sort, right? I have mentioned this earlier. So this is a basic algorithm where you compare and swap adjacent elements until the entire array is sorted. It's simple, but it's not the fastest, as I have already mentioned, right? Right. Then the quick sort, right? Quick sort, on the other hand, is more efficient sorting algorithm. It works by choosing a pivot, dividing the array into two parts, right? Dividing into two parts, and then sorting each part. Much faster for large data sets, right? Much faster for large data sets, right? So, and also insertion sort, selection sort, you need to practice, right? Now today, go home and refer to this material, practice sorting algorithms, right? Then we need to know about some searching algorithms, right? So one of the most common one is binary search, right? So this is a super fast way to search through like sorted data, right? If you have know or heard about time complexity, it is all log n, sorry. which is much better than linear search that we have discussed earlier, right? So for example, let's say if you are searching for a specific number in a sorted array, so binary search will find it quickly by repeatedly dividing the array in half, right? This is especially useful when dealing with large data sets, as I have mentioned, right? So think about that. Try to learn linear search and binary search. Practice those, right? Then the greedy algorithm. So greedy algorithms. I don't know whether you have heard about greedy algorithms. So these algorithms make the best decision at each step, hoping that it will lead to the best overall solution. That's the logic behind these greedy algorithms, right? So for example, let's take an example. So activity selection problem. I'll move scroll down. So I have a very simple example because greedy algorithms are really important. So let's say we have activity selection problem. So which asks you to pick the maximum number of activities that don't overlap, right? That don't overlap. That means, let's say we have these kind of activity list. Activity code is CABFDE, right? So start time would be for the C event, start time would be 0 and the end time would be 6. For the A event, start time would be 1, end time would be 4. B 3 5. Likewise, we have 6 events here having start times and end time. Now the problem asks you to pick the maximum number of activities that don't overlap, right? Maximum number of activities that don't overlap, right? So in a greedy algorithm, it would sort the activities by their end time first, right? So how do in a greedy algorithm, this is how greedy algorithms work, right? So first, what it does is it sorts, right? Sorts by end time. Sorts by end time. So I'm moving into the second step. So sort activities by end time, right? So now we have this list, right? So this is why I have told you in the strategies section, you need to sketch down things, right? So if you take a pen and paper and write this down, then it is easy to come up with a solution, right? So this is how it happens. So if we sort this by the end time, we get this A, B, C, D, E, F events, right? So end time 4, 5, 6, 7, 9, 9, right? So now the activities are ordered by their end times like this, right? Then what it does is it always selects the first activity in the sorted list, right? Which in this case, activity A, because this is the first activity after sorting, activity A, right? Because the start time is 1 and end time is 4. We choose this because it ends the earliest, right? In the step 4, select the next non-overlapping activity. So here, what we look for, the next activity that starts after activity A finishes. So activity A's end time is 4, right? So what we are looking is the next activity that starts after activity A finishes, right? So the next activity that starts at or after 4 is activity D, right? So you can see that. So this is 4. 3, this doesn't work because this is overlapping. 0 doesn't work. But 5 starts after the end time of the activity A, right? So that works. So activity D, so we can select the activity D, right? So we can repeat the process. And finally we are getting the final selection. So the selected activities are A, D, E, non-overlapping activities, right? After D, we got the E because the D's end time is 7, right? So then the only activity left is activity E with the start time of 8, right? After 7, right? So then the AD is the solution, right? So this is the code. So what I need to highlight here is coding is not the important thing, guys, right? So thinking about this solution, come up with a solution like this for a problem is the important thing, right? That's why we need to use a pen and paper and sketch things down, and we need to do everything, and we need to come up with some kind of a like logic, right? Then writing the programming, like writing the program or writing the code is something else. Like we have the logic. Now you need to know about one programming language, Python or Java, then you can write down, right? It's not a big deal. So I asked all of you guys to go through this example because I came to give this problem to you guys and solve it, but I think we don't have much time left. So what I'm going to do is I have explained it kind of in a high level manner. So what you can do is you can just refer to this problem and try to draw everything and come up with your own solution and try to write the code. Not in Python, maybe using Java or something that you're familiar with, right? So do that, right? Okay, now path to success, all right? Okay, I'm talking because I need to wrap everything. I mean, like I need to give everything before end of this session. So that's why I'm rushing through. But anyway, I'll provide this material as well, so you can even refer to these materials, right? So path to success. So what we have covered today is like very important strategies. Understand the problem. If you are participating hackathon or in your career after 1 year or 2 years, if you are maybe you are in a software company, IT firm, so you might encounter some problems. You need to come up with solutions. First thing, understand the problem, read carefully and make sure you know what's been asked, right? Then second one, break the problem down into smaller parts, smaller pieces, right? So into smaller manageable parts, right? That's the second thing. Third one, start with simple test cases, like test your basic logic before scaling up. That's what we have discussed, right? Don't go for 10,000, like kind of a huge numbers to test your simple, your first solution. Start with 2, 4, 5, 10, 100, likewise, just an example, right? Then optimize later. Very important. Get a working solution first. So your first focus is to get the solution, solid foundation, then focus on making it faster, right? Then focus on making it faster, efficient, right? Then think about edge cases, final strategy. Make sure your solution works for all possible inputs, including the unusual ones, weird cases, right? So by following these strategies, you will be able to tackle competitive programming problems like, more effectively, guys. And remember one thing, practice is the key. Without practice, you can't do anything. The more problems you solve, the better you will get. Again, take me as an example. I was an algorithmic programmer or a software engineer 10 years back after graduation, right? For around 4 to 5 years. Hugely focused on algorithmic programming, algorithms, data structures, everything. But now it's been 4 years after that career. I made 360 turn to DevOps and cloud engineering field. Now what happens is I am not using it. I am not practicing algorithmic programming. I am not doing lot programming these days because I am in a whole new area, right? What happens is my touch is gone. Now, if you compete with me, I'm pretty sure one of you guys might win. I'm not going to win because I don't have that touch, and even I am very lazy to do competitive programming these days, right? Because I'm in other goals these days. But for you guys, it is really important to follow these strategies, not just for this competition, guys, but for even for your career, even for your next interview, right? Even you in your next interview might ask a problem and give me a solution. So this is the way you need to come up with the solution. If you follow these 6 strategies, your interview would know, okay, this guy is having some kind of a proper approach. Like he tries to understand the problem. He's asking questions from me, right? And he's breaking down the problem. So you can ask for a paper and pen. You are breaking down the problem, smaller pieces, right? Then you try it with simple test case. Write the small solution, like first version of your solution, and try with simple test cases. Then trying to optimize it. That's the way you need to approach, right? And think about edge cases, right? Okay, enough about that. And preparing for competitions. Again, the final part. If you are gearing up for a competition like IEEE XTreme, here's what you need to do. Again, practice daily. I have repeated this thing I mean, like I was always encouraging you guys to practice, right? Even solving one problem a day will help you improve, right? You can go to HackerRank or even LeetCode and Code Forces. These are the places that you can practice. Practice daily. Solve one problem per day, right? Do it daily. Without practice, you can't do anything, right? And focus on your weak areas, like spend time practicing algorithms and data structures where you struggle, right? If you are not good in algorithms, please go and practice. If you are not good in data structures, then again, try to improve, right? Then join contests. So best way to improve is by participating in time contests, right? Like IEEE contest, right? So you need to do that. So you are going to do that in near day, right? And finally is learn from your mistakes, right? After every contest, review the problems you got wrong and study the solutions. So that's the way to improve yourself as a programmer, as an algorithmic programmer, as a software engineer. Learn from your mistakes. That's how we always, I think I've done hundreds of mistakes at the early stage of my career. So I have done very low amount of things in a proper way at the early stage of my career, but I have done hundreds of mistakes. But I have learned from all these mistakes, right? So that's the way to go. That's the only way you can improve yourself, right? So with consistent practice and the strategies we talked about today, so you will be well on your way to excelling in competitive programming stuff, right? So yeah, that's for today. I think you got some kind of an idea. I was rushing through at the end because I need to cover everything. But again, this is the most important thing. I think this is the most important thing in today's session. And then you need to practice by yourself. So writing codes, if I came here and write a code by myself, it doesn't work, guys, because I have no idea to participate in those competition at this age, right? So but you need to do, so you need to do it by yourself, right? Maybe a team, right? So do it yourself. That's the only way to success, right? Yeah, so that's all about today's session. I hope you get some kind of an understanding around what is competitive programming and what are the strategies, tips and tricks that you can use to success in your next programming competition, or even your next interview, or even in your personal freelancing project, right? So again, before wrapping up my session, I'll move into the Q&A session, but before that, I need to let you know, I got a YouTube channel, so I'm just giving some marketing for my YouTube as well. I'm sorry. So anyway, I got a YouTube channel, so a lot of people are gathering around my community is growing up, so you can just check that out, because I got some trending topics like cloud and DevOps area, not into competitive programming actually, but I'm pretty sure that after a couple of years, when you guys into industry, you will be some of you go into the full stack software engineers, or researchers, or even programmers, but I'm pretty sure 75% of people would come into a cloud and DevOps field, because it's growing and trending. So check out, I got Kubernetes playlist, DevOps playlist, which is kind of a most trending playlist in Sri Lanka. You can check the comments in the channel. So, and you can follow me in LinkedIn as well. So you can click on this LinkedIn link here, and you can follow me, and even you can in touch with me in Facebook and my Discord. So, and again, you can click on this Kodeku here link. So this is again for a platform that I have created for our younger generation, I mean younger software engineers who are willing to join with IT industry. And I got a program called I'm offering some freelancing projects for people like the junior software engineers, interns around Sri Lanka to gain some experience while earning some dollars as well. So I got some few teams as well around me. It's kind of a part-time stuff that I am doing these days, apart from my full-time job. So keep in touch with me, keep in touch with Kodeku, one of these platforms that I have created for you guys. So it would be very helpful for you guys in your future careers, because that's my goal. That's my end goal actually, because career wise I have done a lot of things at this age, and next thing is I need to give something for my country and my people, like my juniors, future software engineers. I need to give something, so I'm offering some free resources and courses future. So keep in touch with me, guys. So, and I wish you all nail down your competition, right? The one which is coming very soon, right? So yeah, thank you guys. So over to you, Tarushi or Sirius. Sorry, yeah, anyone here? I mean, you can move into the Q&A session as well. So you can, what you can do is you can ask questions like even related to IT industry, because I know there are a lot of questions for students these days when it comes to the IT industry, internships and everything, right? So you can ask those stuff as well. Okay, let me answer one question. I saw someone was sharing, is it true software engineers will lose their jobs in the future? Okay, again, a good question. Let me answer this question in a real quick. So the simple answer would be yes, no, right? Yes, no, right? So don't get disappointed, guys, right? So no, I mean, its answer would be yes and no. But the thing is something like this. So, you know, I was entered software industry around 2017 after my graduation, right? 2017. So at that time, we had a very low competition, right? So as a software engineer, for me personally, right? If I have a solid understanding around double OPs and data structures and algorithms, and also problem solving skills and analytical thinking skills, if I have those things, there's a probability that I'll get selected to a good company, right? Because I have the right skill set, right? But in today's world, things are a bit different because the artificial intelligence is kind of a hype, right? You all know AI is there. So what happens is there are tools like, you know, LLMs where they are they are evolving, right? And ChatGPT is here, right? And also GitHub Copilot kind of tools are there. Codium AI is there, right? So Codium AI is another revolutionary tool that I have seen. I have worked with them as well as a freelancer part-time, so I know what it can do, right? So so the thing is, things are a bit different since AI is evolving. So what happens is now the software engineer should be upskilled, right? That means just if you have the data structures algorithms knowledge and double OP knowledge and also the one or two language familiarity, let's say you have these these skills, right? But that is not going to be enough, guys, right? In today's world, if you are going to join with industry, you need to be how to say, you need to have some other skills as well, especially how to use these AI tools and how to come up with a solution with your with the use of AI tools and with your skills and also plus your skills, right? How to come up with a solution, right? So to do that, you need to have some kind of an understanding around AI tools as well. What is GitHub Copilot? How to use GitHub Copilot? How to use ChatGPT to come up with proper logic, right? So you need to have that skill set as well. So at my time, analytical thinking, problem solving, double OP, data structures and algorithm did the job for me. But for you guys, all these plus, you need to have this AI tool, familiarity with AI tools and how to handle these tools and come up with solutions. So you need to have that skill as well, right? But the thing is, guys, I'm going to give advice here. Software engineering is not the only path in this field. Like when it comes to IT field, it's huge. There are hundreds of fields. Like, you know, data science and engineering is there. DevOps engineering is there. Cloud engineering is there. Site reliability engineering is there. Platform engineering is there. Quality assurance engineering is there. Software engineering is there, right? Artificial intelligence is there. Machine learning engineers are there. So I can come up with a huge list because it's a like big, we have hundreds of areas that you can go, right? So what I am suggest here is always try to get the basics of software engineering, like basics of programming. It is very important. So algorithmic programming is also important. Try to get these basics. But after that, don't think about this is the only thing, like coding a product or coding a application, web application. That's not the only thing. We got some demanding and trending fields like DevOps, cloud, site reliability engineering, platform engineering is like it's now going to be a trending one within next 2 to 3 years, right? So we got those type of fields as well. So as a software engineer, what you can do is learn the basics in software engineering and even programming. But after that, it's all about adopting, right? It's all about adopting. So if you know the basics of software engineering, like SDLC, software development lifecycle, if you know the basics, then you can adopt at any time. So because I've done that, guys, I mean, like after 5.5 years, after being a full stack software engineer, I moved, like I made the U-turn, and I became a DevOps and cloud engineer, right? So you can do that too, right? Not only me, I even there are hundreds of people who has done that, right? So you can do that too, right? So that's the answer. So don't get discouraged or disappointed. This is not going to be like software engineering jobs won't be like this role is a must if you are if you are creating a web application or a product. This is a role which is must role, right? But the thing is, you need to have different skill set now, right? So always have a backup plan when choosing IT path. So asking a question, I want to be a DevOps engineer. What should I do after finishing my degree? So okay, backup plan when choosing IT. No, I mean backup plan means, so let's say you are following a software engineering degree to become a software engineer after 4 years, right? That's your plan. But at some point you realize like, okay, now if we apply for an internship, there are hundreds of people apply. And if you apply for a software engineering job role, junior software engineering job role, thousands of applicants are there. So how can I get selected? That's a problem, right? That's a burning question that almost all the people have these days, right? So, but backup plan means, so you don't need to come up with backup plans like, okay, I am following software engineering degree, I am trying to become a software engineer after 4 years. If it if it won't work, I'm going to open up a shop in my village, right? So don't come up with that kind of backup plans, because that's not going to work, because software engineering field is still a trending and most demanding field, right? So what you can do is you can come up with this kind of a backup plan, right? Okay, I am planning to become a software engineer programmer after 4 years after my degree, right? And I'm going to apply to some IT firms and try out and face some interviews and gain the experience. And at the same time, I am trying to learn, like I'm trying to learn some other skills as well. Like I am trying out some cloud skills, DevOps skills, right? So that is very important, right? That's the backup plan that you should have, right? So these days, if you have data structures and algorithms understanding and you have double OP understanding, that is not enough, guys, especially if you are moving from Sri Lanka, like if you are trying to apply for remote opportunities in Singapore, Malaysia or UK. So then what happens is, like if you are a software engineer, they just don't check, they check for algorithms and basic programming skills. It's a must, but at the same time they are checking about whether you have good cloud understanding, because those days we are not using on-premise servers, right? We are now moving towards cloud, not moving towards, actually now we have already moved to the cloud. Cloud is the new normal, right? So if you are a software engineer, your application, the application that you are developing will go into a cloud environment at the end of the day, right? So as a software engineer, you need to have some kind of an understanding about cloud providers as well, like GCP, AWS, Azure. So that is going to be a plus point when you are facing like applying for an interview, there are 100 or 400 applicants, but as a software engineer, you have all the basic programming skills and all these OOP skills plus, right? Plus cloud skills. Then you are going to be highlighted. That's the way you need to have, like, you need to go, like, that's the backup plan that you need to have. At some point, if the software engineer person is not going to work with you, now you can seamlessly move towards cloud engineering role, right? Which is very trendy, very demanding and high salary. And even at the same time, I don't know whether you have heard about these days, there's a term called DevOps. I think someone asked a question, I want to be a DevOps engineer, what should I do after finishing my degree? So the buzzword is DevOps these days, right? What is DevOps? So DevOps is again a kind of a cultural aspect within a IT firm, right? So, you know, I'll give a brief around this because this is really important for you guys. So let's say you are in an IT firm, so they develop some kind of a product, let's say web application. After developing this product or web application, what we need to do is we are not going to keep it with us, right? We are going to publish it for our clients, right? So we need to host or deploy it somewhere. So in this case, we are going to host it in cloud, like Amazon or Azure or even GCP, right? So then what our users can do is they can come to our web application and they can utilize it, right? That's the normal flow, right? So the problem was for the past years, if you have developed some kind of a web application or a product, you need to provide updates and releases frequently. So if you can't provide updates and releases frequently, you can't compete with your competitors. That's the problem with IT firms for the past 10 to 15 years, right? So with the traditional approach, they can't release new updates, new patches as frequently as they wanted, right? That was the problem. Then this DevOps culture being adopted. What DevOps does is, if something slows down your release cycle means after coding your software, developers coding your software, then we test it, we build it, and we deploy it. That's the normal cycle, right? So in traditional environments, in an IT firm, there are things that slows down this process, right? So what DevOps tries to do is, like, if something is slowing down this process, DevOps is targeting to remove that roadblock or barrier and come up with a very streamlined automated process. So that's what DevOps is about. So because of this thing, this DevOps culture, there are, like, you know, the DevOps engineer role being evolved, right? So now DevOps engineer is one of the highest salaried people in the world, right? So what I'm trying to say here is, software engineering is not the developer is not the only thing, guys, right? So you need to have a solid understanding about software engineering basics, programming basics, and SDLC basics. But again, you have hundreds of paths, right? So try to have these kind of backup plans, right? Like having skills on other areas as well. But other areas means, like, now today you go home and don't try to start like, okay, I'm going to have backup plans. I know software engineering, I can do programming. Now I am going to start with 10 backup plans. First backup plan, I am going to follow AI courses, artificial intelligence courses. Then I am going to follow DevOps courses. Then I am going to follow ML courses. Then I am going to follow SRE, QA. That's not going to work, guys. I mean, if you're a software engineer, if you're hoping to be a software engineer, then try to gain some experience or knowledge in the areas of cloud engineering. Cloud, that's one demanding and trending area, right? That's a must, right? Then DevOps area. So these two are very close to software engineers. As a software engineer, you can even like kind of a plus point for your interview. And even at some point, you can make a 160 U-turn, like I've done, to seamlessly move towards DevOps engineering role, cloud engineering role, cloud solution architect role. So you can do that. So have that kind of backup plan, right? That's my advice, right? Yeah, I hope I've given I've done huge explanation here, so I think you got the idea. So any questions you can just if you have any questions in regarding IT industry or your internships, just push, because at the end of the day you are participating in all these programming events, all these competitions, all these sessions, right? At the end of the day, what is your end goal? I mean, what is your end goal? I need an answer now, right? I need an answer. You are participating in competitions, you are doing a degree, you are doing participating in sessions, knowledge sharing sessions, everything. And what is your end goal? What is your end goal? Can someone answer, please? What is your end goal? What are you trying to achieve at the end of, I mean, at the end of the day? What is in your mind? Okay, nothing in mind, right? So I think yeah, more knowledge. Habib says more knowledge. That's correct. So having a more knowledge, what is your end goal? Your end goal is going to be having a proper job, right? That's the end goal. We need to be in a proper IT firm with a proper role, right? And with a proper salary. That's the final goal, guys, right? That's why we are doing all these things. You are in this session today to practice for IEEE competition. Why are you doing IEEE competition? Because you can gain some experience on algorithmic algorithmic problem solving, and having that experience, you can go to your having that experience means you can face your next interview, or you can showcase your certificate in your interview, right? And then getting a job, proper job, right? So more knowledge is indirectly, again, it's about having a proper software engineering job. So always try to upskill, right? So having backup plans is good, but always try to come up with the scope for yourself as well, right? So don't try to learn everything. I mean, I always highlighting this in my sessions. Don't try to learn everything. As a human being, you can't learn everything. You can't learn artificial intelligence, you can't learn DevOps, you can't learn everything. I mean, you need to focus on one thing. I mean, one thing means, so if you are a software engineer, again, you can focus on software engineering basics, but at the same time, cloud part is also there, so you can learn that. And also DevOps aspect is also already there, right? So you can learn DevOps. So likewise, you can learn related stuff for a given area, right? So try to do that and come up with the scope for yourself and practice, right? That's the only way to do this, right? And if you're having any internship problems, or even finding a job, is going to be a difficult task in Sri Lanka these days. I know a lot of huge competition, right? So in that case, again, try to upskill. I mean, have some added skills for your CV, right? So if you are a software engineer, again, having some cloud skills is always good. Having some DevOps skills like CI/CD pipeline skills, or having some knowledge around containers, Docker containers, or Kubernetes, having some knowledge around Kubernetes is always going to be a plus point for you as a software engineer. So try to touch these areas and create a scope for yourself, and follow that scope for next 1 or 2 years. Then you will be having a very structured path and very structured knowledge for you, right? So yeah, any questions other than that? I think it's 9:30. So if you have any questions, I can spend another 5 minutes for you guys. And one thing, so I know you guys are working hard to find internships or even jobs in future. So keep in touch with me. Keep in touch with my LinkedIn because I share some opportunities like from especially from my freelancing projects. Like I'm doing I'm a top rated plus freelance in Upwork freelancing platform. So I'm getting jobs from different clients around the world. So I have a team already, very small team, but I am getting opportunities. So I'm always pushing these projects to students like you, university students, so they can take on some tasks and earn some dollars as well. So keep in touch with me. Yeah. So more on a link, please. So link is yes, Habib. So what you can do is I think Tarushi shared the shared and she shared a link here, the Codeco.tech Decode Extreme. So you can click on that link and you can go to the home in that web as well, right? So this pinned one. So you can go to the Codeco.tech. So you have all the necessary details there. So you can sign up for my Codeco's LMS platform as well. So keep in touch with my LinkedIn as well. So I'm trying my best to help you all. Yeah. Any questions, guys? Feel free to ask.
Sir, I have a question.
Yeah, Maya. Yeah.
How do you manage mental fatigue and maintain focus during long coding competitions, especially when the pressure builds up?
Yeah. This is again a good question. So yeah, again, so one thing, Omaya, I think you have seen the 6 strategies that I have shared with you guys. So I think if you are stressing, or if you are feeling like pressure is building up, if you feel like that, I think there's something wrong in the way that you have approached the problem. Like maybe you have read the problem, or you have understood the problem, but again you might be straight into coding, like without breaking that into smaller pieces. So what my advice is, once you understand the question or a problem, then you need to do is the most important thing is breaking down it into smaller pieces. Then you will not be having any pressure or stress, because after having smaller pieces, your goal is to like take the first piece and solve that, or take the first piece and think only about how to have a logic or solution for that part, right? After have the proper solution or logic for that part, keep that away and then approach the next one. Likewise, if you can break down this problem into smaller problems, I'm pretty sure this is what I have done. Because in my time, I mean, like few years back when I was doing this stuff, so like in my first competition, I think I was a bit nervous because it was my first competition, right? But my advice is like, just don't get nervous. It's up to you. Just think about it as just a normal thing. Think it as an opportunity for you. It's not the end of the world, right? This is going to be a very good opportunity for you guys to have some problems and come up with solutions within a given time period. So think it as an opportunity for your future and to gain some experience or skills around algorithmic programming. Think it think as it, right? So then approach the problem, understand the problem, as I have already mentioned, right? Then break it into smaller pieces. Breaking into smaller pieces means you won't be having any stress. So I don't think pressure would build up, because having smaller pieces means you need to focus on only atomic part of the problem, right? So at one time, right? So that's the only way that I can think of having a good mental have to approach your questions or your problems, I mean the competition problems, without a stress, right? So yeah, you can follow that way. Important thing is breaking down the problem and understand the problem first. So that and come up with the most simplest solution as soon as possible, right? So once you have the small pieces, come up with the most simplest solution. Don't think about perfect solutions, because you can't come up with perfect. If you are going to think about perfect solutions, that's the that is where you are going to build up the pressure, right? If you are going to think about, because when you are trying to think about perfect solutions, that means you are trying it in like in a very complex manner, right? So you are trying to make things complex because you are trying the perfect answer, perfect solution. So don't go in that way, right? So just keep calm and think about it as an opportunity for you guys to gain your skills. That's how you need to think about when you are starting the competition. And then once you have the problem, take the problem, read it, understand the problem, have a pencil and pen and paper, sketch down. If you don't understand something, sketch down and think about it again, right? Then break it down into smaller pieces and try to solve one by one. At the end of the day, you will be I mean, you will be like getting success on most of the questions in the competition. So try that way. So that's the only way, I think. Oh Maya, yep. I hope you got the answer. Yeah, right. Yeah. Okay, so I think yeah, okay, got it. Yeah. So don't build up the pressure. So just think it as something think it as like you are trying out some trying out some codes. Just think it as like that, right? So don't think about it. So it's IEEE, it's a competition. Don't think like that. So don't build up unnecessary pressure with these emotions, right? So yeah. Okay, so I think it's 9:40. I think there are no questions. So if you have any questions, again, contact me in LinkedIn. You can just send me a direct message, or even you can send support message to Codeco platform. If you go to the web page, you have a support. There you can even ask questions, so you can send your questions to me or my team. So we are willing to answer. So any question, yeah. Okay, so I think it's 9:40. I think there are no questions. I think I have answered almost all the generic questions, like how software engineering field is working these days, and how to upskill as a software engineer, and how to face an interview, and how to face competition. So the whole session is all about facing the competition using these 6 strategies, right? So I think that's the end, right? So Maya, or sorry, or not Maya, or Tarushi, or someone. So what is the next, guys?
A heartfelt thanks to you, Mr. Nimesh Jinarajadasa, for your immense support and guidance throughout this journey and for the success of this event. We have prepared a small token of appreciation for you. So please accept this, sir, with our most sincere gratitude. Your endorsement and encouragement are invaluable to us, and we deeply appreciate the time you have taken to be with us.
Okay, thank you very much. Thank you very much, who is this, Rusiru and Tarushi. So everyone who is, I mean, like, thank you very much for inviting for this session. So I really like to share my knowledge with people like you. This is my 6th session in the year, 6th institute. So thank you very much for this token. Yep.
Before we conclude, I would like to inform everyone that the link to access this session materials has been shared in the chat box. Please feel free to click on the link or save it for the later reference. As we are slowly reaching the end of our session and the webinar series, before we conclude the event, I would like to invite all of you to switch on your cameras to capture this cheeriest moment. I'll give you guys 1 minute to get ready, and then we will capture the moment. In countdown to 3, please guys, join with us. 3, 2, 1. Thank you everyone who participated with us. As we draw our event to close, I would like to invite Mr. Aminta Jayasuriya, Assistant Secretary of DECODE XTREME, to deliver the vote of thanks. Over to you, Mr. Aminta.
Good evening, everyone. As we wrap up this enriching DECODE XTREME webinar series, on behalf of the organizing committee, I want to express heartfelt gratitude to everyone who made this event possible. Firstly, a special thank you to our esteemed guest speaker, Mr. Nimesh Jinarajadasa. Your insight and advice on IEEE Extreme have truly inspired and empowered us. We greatly appreciate the time and expertise you have shared with us. A huge thanks to executive committees of the IEEE Student Branch of the SLTC and the IEEE Computer Society Student Branch Chapter of your support in organizing in this event. Your guidance has transformed DECODE XTREME into a platform for growth and collaboration. To our organizing committee, volunteers, and technical supporters, your behind-the-scenes work ensured everything ran smoothly. Lastly, thank you to our enthusiastic participants and supporters. Your engagement and support have made this event a success. Thank you all and have a great evening.
Thank you, Ms. Aminta, for those heartfelt words. And a special thank to you all, our guest speaker, special guest, and everyone who joined us tonight. We trust this event has sparked both inspiration and valuable insights, leaving you with a new perspectives and ideas to take forward. Thank you, everyone, and have a wonderful day.